Okay, last time we did exponent rules earlier this week. Today we're going to do exponent rules that are algebra 2 levels. I only got to the algebra 1 level ones on the notes from last time. So here's notes from last time. We only did these 4. We only used those 4. So I have to use some of these just to show you how it's like in algebra 2 level. So we're going to do some examples. You ready? Let's go. Okay, so here we're bringing in fractions. Now here's the thing. If these were both 2, I could just add up the powers because it's multiply. But they're not both 2, so I have to change it a little bit. So a 4 is a 2 squared. So I'm actually going to change that 4 into being a 2 squared. I didn't change the problem at all. Nothing's different. I just made the 4 into a 2 squared. Now, I know my exponent rules for powers to powers is to multiply them together. So this is actually 2 to the 3/4 times 2 to the 10/4. Okay, now here, if fractions are scary, just roll with it, okay? When I do a multiplication here, I just multiply the top. I don't worry about the bottom. I could actually simplify this, but I want them both to be the same bottom so that way they're both a 4. So I'm not going to do that. Okay, so now I can add these powers up. So I actually have 2 to the power of 13/4. Now this is what's called exponential form, which literally just means that they're in exponents. And then radical form means that we use that fifth rule to make this root or this over 4 into a root 4. So normally what we do is we have the whatever root of 2 to the 13th. Well, that's the fourth root of 2 to the 13th. So I took that 4 and put it in the little placeholder. This is right here. It's called the index. I don't think I told you this last year. And this is radical. I know I didn't have you last year. I just meant like, I didn't write that down on here last year. I probably should have. So that's the index of radical form. So either exponential form or radical form are my final answer. It depends on what it's asking for. It'll just say simplify at the top. I'm going to add the steps on the side. Okay, power to power means multiply. Multiply means add. If this doesn't make sense to you, please make it your own. So change it to make sure that you know what I did. That way later you can go back without needing to watch this again. You can just do it in your notes. All right, let's talk about the fourth root of 405x to the 7th. I want to simplify this, which means I want to do the square root or the fourth root in this case, but I need to know what that means. Okay, so square roots mean something times something, right? 3 times 3 is 9, so the square root of 9 is 3 because 3 times 3 makes 9. Okay, so I'm trying to figure out what times what times what times what makes 405 and what times what times what times what makes x to the 7th. So let's talk about this. So I don't necessarily know what times what times what times what makes 405. So I'm going to do this thing called a factor tree. So my factor tree is going to be to divide 405 by whatever I know it divides by. The only thing that I personally know right now that it divides by is probably 5. So I know that 405 divides by 5. And I'm going to take my calculator, which is over here. And I'm going to do that. I'm going to figure out what 5 times what makes 405. So 405 divided by 5 is 81. Okay, well, what times what makes 81? Okay, well, I know that 9 times 9 makes 81. And I'm going to keep going as far as I can. 3 times 3 makes 9. The only thing that I don't want to do on here is prime numbers. Or sorry, the thing I don't want to do on here is 1. I want prime numbers at the end. So this is called the prime factorization. So 405 is 5 times 3 times 3 times 3 times 3. Okay, now I'm looking for sets of 4 because this is a 4 in here. But if it was a 3 in here, I'd look for sets of 3. If it was a 17 in here, I'd look for sets of 17. But I want sets of 4. Okay. Now I'm going to do the prime factorization of x to the 7th as well, but I don't need to do like x times whatever. So x to the 7th is x times x times x times x times x times x times x. Got it. Okay. So I'm also looking for sets of 4. Okay. So here's what I'm doing. This confuses people every year, so I'm trying to make it more clear because you're virtual right now, so I can't see your faces of confusion, but I want to understand this. So this is basically the fourth root of 5 times 3 to the 4th times x to the 4th times x cubed. Okay. Now, if there's ever a power of 4, I can take it out because the fourth root of something to the fourth cancels. We kind of learned this last trimester at the very end where square roots canceled squares. Fourth roots cancel powers of 4. So this 3 is going to get canceled with that 4. And this x is going to get canceled with that 4. But the 5 doesn't get canceled and the x to the third doesn't get canceled. So they stay inside. They're so sad and lonely. They stay inside. So that's my final answer. Oh, here's a question you might have is why didn't this 4 just go away? Well, it's because I can't take the fourth root of 5, but I can take the fourth root of 3 to the fourth. I can take the fourth root of x to the fourth, but I can't take the fourth root of x to the third. So only the things that have the same powers can come out of the house. All the rest stay inside, so I still need this fourth root to be here. All right, last one. Okay, so for this one, I'm going to just simplify this. All of these say simplify, by the way. That's just the explanation of what to do. So we need to know what to do from that. So I'm going to ignore the square root for a second and just work on the inside. Okay, so just like last time, I'm actually going to put the square root there, but we're going to ignore it for just a second. Okay, so just like last time, I'm going to do just the normal numbers, just the x's, and just the y's. They have their own little section. Okay, so 75 over 3, I think that's 25. 350, yeah. Okay, so that's 25. And then remember I subtract, right? I subtract when it's division. So x to the fourth minus x to the 1 is x to the third. And then subtract, and this was actually just division. So y to the 7th over y to the negative 1. If I do 7 minus minus 1, that's a plus. So this is actually y to the 8th. And this whole thing is still inside the square root. So I'm going to have to undo the square root now. Well, okay, I don't need to make a prime factorization for the 25 because 25 is chef's kiss. It's just 5 times 5. Okay, so I'm going to bring this down here. So 5 times 5. And then I have 3 x's multiplied together. So I can take one set of 2 out. It'll be like an x squared and I take that out. I don't want to show that step, but it's the same as I did up here. And then I'd still have an x on the inside. And I'm leaving space because I want to do the y's out here too. Okay, so then this is y times 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 y. Gross. How many sets of 2 do I have in 8 y's? 1, 2, 3, 4. So I can take out y to the 4th. And I only have the poor little sad x inside. Okay, now not for you, but for everybody else, I'm going to write, watch the video. Because some of you got lazy. Some of you don't have time. But this is a really important one to watch the video, so I'm just going to put this down here so that way people freaking come and watch the video because it'll help a lot so they don't get confused and ask me questions. Okay? Okay. Hey, do you have any questions? Email me. Let me know. Please tell me if you have questions, as I want to help you. I am here to help. That's all. Okay, bye.